So this is the formula which we've got, okay? We've got two ways of defining u dot v. You've got u1, u2, u3 for u, and let's say v is equal to v1, v2, and v3, okay? We know one way of defining u dot v will be equal to u1 times v1 plus u2 times v2 plus u3 times v3. We proved that in the last hour, okay? The other way of defining u dot v is by finding the length of u, the length of v, multiplying them together, and then if you know the angle between those two vectors, multiply them by the cosine of that angle. Okay?
Sorry, can I interrupt?
Yes?
How can you find the distance with the 3 points, with u1, u2, and u3?
Easy. Okay, so the distance of u would be exactly the same as the distance in two directions. Okay? So u modulus will just be u1 squared plus u2 squared plus u3 squared square rooted. It's exactly the same idea as in two dimensions.
Okay,
Yeah? That's a good question, actually. Yeah, that's a really good question. Okay? And the same with v. Yeah, so you just take each component, square it, add it together, take the square root, simple. All right? Okay, so fine, we've got two ways of defining the dot product. You happy this one is probably not the most useful form that you want it in. It's the one given in the formula booklet, okay? But it's probably not the most useful form. Because if you wanted to work out u dot v, right, that's easy to work out. But finding the angle between the two vectors, you're probably not going to be given that. So actually the most useful way of using this formula is to literally find the angle between the two vectors. In other words, you solve it for cosine of theta. Okay, so you solve it for this. In other words, I'm saying the angle between the two vectors, or at least the cosine of the angle between the two vectors, will just be the dot product of u and v, that's easy to find, divided by the length of u, that's easy to find, divided by the length of v. That's also easy to find. Everything on the right-hand side is easy. Yeah? Everything on the right-hand side is easy. Are there any questions about this? Let me show it to you in action, because I appreciate there's loads of like u's and v's and thetas and things throwing out on the board. Let me just show you how easy it is to use. So let's suppose we had a question which says, find the angle between, okay, let's say that u, just give me three numbers for u.
6.
Yep. Yep.
4.
4. All right. And let's say that v, another three numbers, make some of them negative for me.
3.
Yep.
-2.
Yep.
-6.
-6. Cool. Okay. So there you go. All I want to do is find the angle between those two vectors. Right? Nice and simple. I just think about this formula here. Just think about this formula here. So this is the formula given in the formula booklet. You're happy you can rearrange it for this formula. Just divide through by that thing there together. Is that okay? Is everybody familiar with how to get from here to here? No questions? Good. Okay. So let's think about what I need. First things first, I actually need the dot product of those two vectors. So the dot product of u and v, how would I do that?
So u1 times v1 plus v2.
Exactly. So 6 times 3 plus 8 times -2 plus 4 times by -6. Just simply multiply corresponding elements together, then add them. So what do I get?
18 into 16, that's 2 plus -24. So 2 plus -22. Is it?
Yeah.
Yep, -22. Good. Okay, it's -22. Okay. Now all I need is the modulus of u. So the modulus of u is also nice and easy to find. Modulus of u will be 6 squared plus 8 squared plus 4 squared square rooted. That thing squared plus that thing squared plus that thing squared square rooted. Okay. Can somebody calculate that for me? Because I can't be bothered in my head. It's going to be 116, I think.
You already did it?
Yeah.
Plus 4 squared?
Yep. Square root.
2 square root 29.
Yeah, okay, it's fine. 2 square root 29. Okay, good. And then what about the modulus of v? So the modulus of v will just be 3 squared plus -2 squared. Remember to put brackets in. Plus -6 squared. Square rooted.
3, 2 plus 6, right?
3 squared plus 2 squared plus 6 squared, if you like.
Plus 7.
What do we get?
Plus
7?
7. Yeah.
Oh, because it's 49. There you go. Okay. Now all I do is I just utilize this formula and I'm away. So I'm literally saying that the cosine of theta cosine of theta should be equal to the dot product of the two vectors. I've got that. It's negative 22. That's negative 22 there. Divided by the modulus of u, the length of u, I've got that. It's 2 root 29. Okay? Times by the modulus of v, the length of v. I've also got that. It's 7. So I just multiply 3 by 7. Okay? Stick all that in your calculator. What do you get?
27 over 2 square root 29.
Is it negative 11 over 7 root 29?
It's negative 0.35.
Okay, that's fine as a decimal. So is it negative 0.35?
36
36, okay. Okay. Now remember, I don't want cos theta, I want theta. I want the angle between the two vectors. How would I find theta? Absolutely, take the cosine inverse of that negative 0.36. So what do we get?
110.96.
110.96 degrees.
Can I take the shell out?
Yes, absolutely.